Hi student, hello, good evening. So today we are going to do the question number 63. Okay, so question number 63 is what? There is a waveguide. Okay, so a waveguide. This is question number 63. Question number 63 is about a waveguide whose dimension, there is a waveguide whose dimension A, broader dimension, that is 15 millimeter. Yes, 15 millimeter, and B, narrower dimension, that is 7.55 millimeter. Yes, 7.5 millimeter. So this is given. So then after that he's saying that minimum it is used as a high pass filter. Okay, so used as what? High pass filter. High pass filter. It is used as a high pass filter. Okay, so then after that, if stop band attenuation required at 8 gigahertz, okay, 8 gigahertz, saying that at operating frequency of what? 8 gigahertz, 8 gigahertz, there is a what? There is a stop band attenuation. Stop band attenuation. So how much is this stop band attenuation? That is given as 109.2 dB. 2 dB. Okay. So then what is the length of filter? What is the length of filter? He is asking the length of filter. Okay. Assume the conductor loss is 0. So these are the conductor losses, which is 0, and 1 Nipper per meter, 1 Nipper value. 1 Nipper value is given as 8.69 dB. Okay, 69 dB. So now here we have to calculate what? We have to calculate length of the filter, and this waveguide is acting as a high pass filter. High pass filter. Okay, so here the signal is propagating through this waveguide. Okay, so through this waveguide, and that signal will get attenuated after traveling some particular distance. Okay, so that particular distance here is nothing but the length of filter. So we have to find that, and is given that at this point, at this length, the signal will get attenuated by a factor of this alpha. S is given as 109.2 dB in dB. Okay, so now see here. Now see how we can calculate this. Initially, we have to assume that here the signal is how much? Signal is E naught. Okay, so because when the signal is at one end of this waveguide, so that time its value, let us say its value is what? E naught. As the signal travel through this waveguide. Okay, so through this waveguide, as the signal travel, means as this signal propagates through this waveguide, it will get attenuated. Okay, it will get gradually attenuated at some particular distance, let us say L. Here its value is nothing but its value will get what? Reduced by a factor of what? Factor of alpha S. This is attenuation factor. Okay, so how much is this attenuation factor? At this point, this value will get attenuated. Okay, so this is nothing but E naught L. Okay, so E naught L. So this is the value. Okay, here length at length, this value is nothing but E naught L. Okay, E naught L. So that we have to find. This is the length of filter. Okay, so length of the filter, and this is what? Distance. Okay, so distance. Now let us see how we can write the equation of this signal which is propagating through the waveguide. Okay, along the axis of the waveguide. Okay, so in term of what? Length L. So this is nothing but E naught L. E naught L is equal to E naught. This is what? Initially the signal value is E naught voltage. Okay, so this is e to the power minus alpha. What? Minus alpha L. Okay, so this is the value. If you see, this is the equation for this signal propagating through the waveguide, which is gradually decreasing as the signal is traveling, or propagating through the waveguide. Okay, so now see here. Now, what is our main target? First of all, we want to find this one. Let us first find this E naught L. Okay, so E naught L, if you see here, E naught L value. So this is what? This is decreased. Okay, this is what? Reduced by this factor alpha S, attenuation factor. So this attenuation factor. So now see, this is nothing but alpha S into E naught. So now this alpha S is given in dB. So let us first convert this dV into what? Linear. Okay, so linear. This is alpha s is equal to 109.2 dB. Okay, to dB. So now let us convert this into linear. Linear. So this is what? Minus 109. Why minus? Because it is attenuation. Okay, attenuation means it is decreasing. So 109 is equal to 20. Why? Because it is a what? Voltage signal. It's not a power signal. Okay, so this is a voltage or current signal. Okay, so this is a signal. This is not a power. Okay, signal. So that's why 20 log 20 log 20 log alpha s is equal to what? If you see, if we will divide this, what we will get here? So this is nothing but 10.92. 10.92 divided by 2 is equal to log alpha s. Log alpha s. Okay, so now alpha s is nothing but linearly, if we say, this is nothing but 10. Okay, so this natural log will go this side, this log will come this side. Okay, so log base 10, this is log base 10. So 10 to the power how much? This is negative, so negative 10.92 divided by 2. Okay, so which is nothing but 10 to the power minus 5.42. Yes, if we will divide this, how much we will get here? 5.46. Yes, 5.46. So now, so this is my value of alpha s. Alpha s. Okay, alpha s value is this. So now just put this value, alpha s value here. What we will get now? So I am going to draw this. So this is what? So now see, E naught alpha L is nothing but E naught alpha, E naught L is nothing but alpha S value is nothing but 10 to the power minus 5.46. 46 E naught. 46 E naught. Okay. So now put this value here. What we will get? 10 to the power minus 5.46. 10 to the power minus 5.46. Okay, so this is how much? 10 to the power minus 5.46. 46 E naught is equal to E naught e to the power minus alpha L. Okay, alpha L, E naught get cancelled. Okay, so get cancelled out. So now this is how much? 10 to the power minus 5.46 is nothing but 3.467 into 10 to the power minus 6 is equal to, okay, so when you will solve this, you will get this 3.467. So 10 to the power minus 5 is there. Okay, 10 to the power minus 5 value is there, and 10 to the power minus 4.46 value is 3.467. 0.3467. Okay, so 10 to the power minus 0.46 is nothing but 0.346, and this is nothing but 3.46. Overall value 10 to the power minus 6. So which is equal to what? Minus alpha L. Minus alpha L. Okay, so now minus alpha L. So let us take the natural log on both sides. What we will get? So this is up to this. Okay, so let us rub this. Let me rub first. Okay, so just wait. So this is what? See, minus alpha L is equal to, taking natural log on both sides. So this is ln 3.467 into 10 to the power minus 6. So this is actually 3.42. Yes, 3.42. So this is coming minus 12.58. Yes, minus 12.58. This will get cancelled, and we will get here length. Value of length of the filter L is equal to 12.58. 12.58 divided by, so 12.58 divided by alpha. Okay, final expression. Okay, so now we are targeting about alpha. Okay, so everything we have calculated. Now we are left with alpha. Okay, so now how to calculate alpha? Alpha is what? Attenuation factor. Attenuation. Okay, so alpha is attenuation. First of all, we want to We want to calculate this. Okay. After that, we will come to the solution of what this the length of filter. Now see. So this everything we have calculated. What is this? Alpha attenuation factor. Okay. So by which this strength of the signal will get reduced. Okay. So reduced at what? At a distance of L at this frequency, at this operating frequency 8 gigahertz. Okay. So 8 gigahertz. So let us see. This is 12.58. This we know 12.58. Okay. So now see 12.58. Okay. So this is what L is equal to 12.58. L is equal to 12.58 divided by what? Alpha. Alpha. Now see alpha. Now how to calculate alpha? As we know very well what propagation constant. Propagation constant alpha is equal to alpha plus propagation constant gamma is equal to alpha plus j beta. J beta. Okay. So which is equal to what? Which is equal to square root of m pi by a. M pi by a. M pi by a whole square plus n pi by b whole square minus omega square mu epsilon. Okay, omega square mu epsilon. So this is what actually the cutoff frequency value. Okay, for this is the cutoff frequency for the rectangular waveguide. Okay, so now we are seeing this for what? TE10 mod. For TE10 mod, dominant mod. For dominant mod. For dominant mod. For dominant mod. For dominant mod, if you see here, for dominant mod, TE what? TE10 mod. TE10 mod, which implies that M is equal to what? 1 and N is equal to what? 0. So these M and N are what? Mods. Okay, so these are half field variation. These are what? Half field variation. Half field variation along what? Along the length of the waveguide. Okay, so half field variation. So now this N is equal to 0. Okay, half field variation along broader side, along narrower side is 0, and half field variation for along the broader side, along the length of the waveguide is what? M is equal to 1. Okay, so now see just here the gamma is equal to what? Gamma is equal to alpha plus j beta. J beta is equal to what? Square root of what? Square root of n pi by a whole square minus as n is equal to 0, we are left with what? Omega square mu epsilon. Now let us see. So now just here is the point is that this is what this is asking. Here we just want to what? Calculate alpha attenuation factor. Okay, so when it will be possible, when the attenuation is possible. Okay, so when this attenuation is possible through the waveguide, through the rectangular waveguide, this is possible only if the wave will get attenuated. When the wave will get attenuated, this will get attenuated only if this part is what? Real inside this square root. If this total part is what? Positive means what? As we know very well that alpha attenuation factor is what? This is what? Real part, real and positive. Whenever we will get this real and positive, then only we can say that this is the value of alpha. Now if this factor will come what? Negative, less than 0, then it is under square root. Negative value of any negative value under square root is nothing but that is imaginary. Imaginary means what? That the wave that is propagating through the waveguide will what? Completely propagate through the waveguide, and there is no attenuation at all. Okay, so therefore we can say that if we want to attenuate this signal, so for this factor should be what? Less than 0. For that, pi by a whole square minus omega square mu epsilon should be what? 0. Then only we can say that this factor will come positive, and therefore the alpha will become positive, and definitely the whatever the signal that is propagating through the waveguide will get attenuated. Okay, so now see here, just we will put all these values. Okay, so just plug this all value inside this square root, and we will see what is coming. Okay, if it is coming positive, so definitely the value is what, alpha, that value is alpha. If it is coming negative, means what, we cannot calculate what, length of the filter. Why? Because if it will come negative, then definitely the wave that is propagating through the waveguide will not attenuate at all, and it will pass through the waveguide. Okay, so let us put all this value, what we will get here. So this is nothing but square root of what, square root of pi, pi by a is what, 15 millimeter, so 10 to the power minus 3 whole square. Yes, whole square minus, what is this, omega means 2 pi f. Okay, so this is nothing but 4 pi square, 4 pi square 4 pi square f square. How much is f there? 8 gigahertz. How much? 8 gigahertz, which is nothing but 64 into 10 to the power 10 to the power 18, 10 to the power 18, 18 into mu epsilon. Mu epsilon means what? This is nothing but 1 by c square. 1 by c square. 1 by c square means, as we know very well, c is equal to what? C is equal to 1 by square root of mu epsilon. Mu epsilon. Okay. So now see here. This is mu naught epsilon, whose value is nothing but, this is nothing but velocity of light. So whose value is nothing but 3 into 3. This is c square. Okay. C square means it is a 9 into 10 to the power 9 into 10 to the power 60. 10 to the power 60. Okay. So now let me remove first these portions. Okay. So this is, now this is what, gamma. Gamma is equal to what? Square root of, let us take this pi value, constant means common from both sides. Okay, so we will get at outside pi. Okay, so pi into square root of what? Pi into square root of, this is 1 by 15. So that is nothing but 10 to the power 6 divided by 10 to the power 6 divided by 2 to 5, 2 to 5. Okay, 2 to 5 minus this is what, 64 into 4, 4 16 4 6 25, 25600, 100. Okay, 25600. So because this will come upside, this is what, 100. Okay, so now then we will solve this, and here downside it is what, 9. Okay, so now this is pi square root of what, square root of, if you will solve this, what we will get, 1 by 2 to 5. 2 to 5 means what, it will come 444 minus when we will solve this, 25600 by 9, so it will come to 844.44. Yes. So now when you will solve this, so this will come, gamma is equal to what, gamma is equal to pi square root of it will come 15 9.99. Yes. So this is approximately equal to what, pi into what, pi into 1600. Yes, 1600. So which is nothing but 40 pi. Yes. What is the value of gamma? Gamma is nothing but 40 pi. From here we can say that it is alpha plus j beta. Where beta phase constant is what, 0, and alpha attenuation constant is how much, 40 pi. Yes, 40 pi. Now we have reached up to this value. Okay, alpha is equal to 40 pi. So there is no need to convert this into dB. Why? Because we have already converted this attenuation factor into what, linear. Okay, so there is no need to convert this alpha attenuation factor into what, dB. Okay, so keep it as it is. Okay, so remain same, and we will put this into here, and we will get the value of what, length of the filter. So now see here, what is the final result? So final result is nothing but, as we have got both alpha is equal to 40 pi, and from there we have got L is equal to 12.58. Okay, so now see here, what is this L, length is equal to 12.58 divided by what, divided by alpha. Okay, this 12.58 that we have got through this attenuation constant. Yes, through this what attenuation factor, where this signal will get attenuated by a factor of what 109.2 dB at a distance of what L, at a distance of L. From there we have solved. Okay, so because we have converted this into linear, then alpha should be in linear. Okay, so therefore both are in linear, so therefore it will come 12.58 divided by alpha is 40 pi. 40 pi. Yes, alpha is 40 pi. When we will solve, we will get approximately it as zero point 0.1 meter. 0.1 meter. So therefore, length of the filter is how much? Length of the filter in term of centimeter. This is 10 centimeter. Yes, in term of millimeter, this is nothing but 100 millimeter. 100 millimeter. Yes, 100 millimeter. As the option is given in term of what? Millimeter. In term of millimeter. So therefore, this is our final answer. This is the length of what? Filter. Length of filter is how much? Length of the filter is 100 millimeter. So therefore, option A is correct for this question. Okay, option A is correct. Option A is correct. Okay, so now the key point here is what? What is the key point here? Okay, so this is what final answer, length of the filter, 100 millimeter. 100 millimeter. So about this question, whatever the question will come related to what length of the filter, where we have to focus first of all, the problem will come while solving the attenuation factor. While solving attenuation factor. Okay, attenuation factor. As we know very well what attenuation factor is there. This is what gamma. Alpha plus j beta. Gamma alpha plus j beta. Yes, what exactly the alpha indicate? Alpha indicates what? Attenuation. What? Attenuation of the wave. This indicate attenuation. Yes, attenuation of what? Attenuation of what? Of wave. Attenuation of wave. Yes, wave propagating through the waveguide. And this beta indicate what? Beta indicate the propagation. Yes, propagation of wave. Attenuation of wave, propagation of wave. And this attenuation factor, attenuation of the wave unit is what? Nepper per meter. Yes, and where one nepper is nothing but 8.68 dB. Yes, 8.68 dB per meter. Yes, in term of what? In term of dB. We can say 1 nepper is equal to 8.6 dB per meter. If we see propagation of the wave, this is what beta. That beta indicate what? Propagation of the wave. Beta means if the beta is not 0, means definitely the wave which is propagating, the wave through the waveguide, the signal through the waveguide will propagate. Okay, so there is a propagation. So whose unit is nothing but radian per meter. Yes, radian per meter. So then will come the question about what if alpha, if gamma is what? If gamma is less than 0. Now, if m pi by a whole square plus m pi by a whole square plus m pi by b whole square. If this factor is greater than omega square mu epsilon. This implies what? Alpha. Alpha. Once we will get this implies alpha. Okay, if it is less than omega square mu epsilon, if it is less than this, okay, if it is less than omega square mu epsilon, okay, mu epsilon, then it implies what? Beta. This means wave is propagating. This means wave get attenuated, wave get propagated through what? Waveguide. So beta is nothing but omega into square root of mu epsilon. Okay, beta is equal to what? Omega into square root of mu epsilon. Okay, so you can write omega by Vp. Yes, omega by Vp. So this attenuation factor alpha. Yes, this is what? Attenuation. This attenuation factor alpha. So alpha, it will come only if this factor is what? Positive. This factor is positive. From here alpha we can calculate. If it is coming real. Okay. So now once we will get alpha value, once we will get alpha value, then we can put this easily into what this expression where the signal is propagating through the waveguide and will get attenuated by a factor of what, by a factor, by some factor. Okay, so this is what E naught e to the power minus alpha L minus alpha L, and this is what reduced what signal, okay, at some distance L, some distance L. Okay, so here we, in this expression we have to put all those value. Okay, so from here either they can ask about this attenuation factor, they can ask about this length of the filter. Okay, so they can ask also about this, what about this attenuation, how much amount this signal will get attenuated if this attenuation constant is given and length of the filter is given, and then we can easily calculate. Okay, so this is all about this attenuation. Okay, so length of the filter. So this is all about question number 63. So thank you very much to support my channel. Okay, so that's all for today.